All right, what we're looking at today is the law of sines. Now, the next couple of days we're going to be looking at law of sines and law of cosines. We need to remember that sine, cosine, tangent, and their buddy are wonderful things, but they're limited. What situation do sine, cosine, tangent, and their buddies work in? Right triangles. They are limited to only having triangles that have a right angle in them. We should know that not every triangle in the world is going to be a right triangle, which means that we need what is called the law of sines, and then the next few days, what is called the law of cosines. Now, because we are going to use them when they are not right triangles. In situations where we are looking at things that are not right triangles. Hopefully from geometry last year we remember the law of sines. The sine of angle A over little a is equal to the sine of angle B over the side opposite it. Little b is equal to the sine of angle C over the side opposite it, which is little c. Okay, so far so good? Bringing back fond memories, hopefully. Okay, so as we look at this, we're going to take a look at triangle ABC. All right, we know for every single one of these we're going to draw a triangle. ABC across from angle A is little a, across from angle B is little b, across from angle C is little c. And we are going to look at particularly what information is given to us. So they tell me that angle B is 118 degrees, angle C is 36 degrees, and little c, the side opposite angle C, is 14 inches. Now, law of sines is wonderful. We don't have a right triangle here. I don't have a right angle. I know that I want to use law of sines when I have an angle and the side across from it. If I have one pair where I have an angle and the side across from it, law of sines will make the most sense. All right, I'm going to set up law of sines. So, sine of angle A, we don't know him, over little a, we don't know him as well, is equal to the sine of angle B, which is 118, over little b, which we don't know, is equal to the sine of angle C, which is 36, over little c, which is 14. Now, you will know you made a great choice. You will know you made a great choice when we are given one fraction that has both pieces. If I have one fraction, one ratio that is completely full, I will know law of sines makes the most sense. Okay, now, in this fraction, I don't know either piece. In this fraction, I am only missing one of the pieces. So I know that the first proportion, the first fraction equal to a fraction that I'm going to be setting up is the sine of 118 over little b equal to the sine of 36 over 14. All right, how do we solve this? Absolutely. Fraction equal to a fraction, we're going to cross multiply. 14 times the sine of 118 is equal to little b times the sine of 36. All right, now we are going to minimize how many calculations we write down in our work. If I want to get little b all by itself, what am I going to do? Divide by the sine of 36. So I'm just going to keep that as the sine of 36. I'm not going to have cruddy decimals. So little b is equal to, now this is one set of keystrokes in my calculator. I should realize that my mode needs to be in degrees because both of the angles that are given to me are in degrees. So I should realize that my mode on my calculator needs to be in degrees because my angles that I'm given are in degrees. Then I'm going to take 14. I'm going to multiply by the sine of 118, and I'm going to divide it by the sine of 36. Does somebody have that? 21.03. All right. And that is inches. Perfect. We are going to be nearest hundredth for everything. Nearest hundredth for everything. So little b is 21.03 inches. Any issues so far? All right. Now, any thoughts on anything else I could do? Yeah. Oh, yeah. We could have found angle A a long time ago, couldn't we have? We could have found angle A long time ago. Angle A is actually going to be, how do I find it? Very nice. 180, subtract 118, subtract the 36. So angle A is how much? Beautiful. I could have found that third angle right away if I had wanted to. Now, I'm going to set up the law of sines once again. So the sine of my angle A, which is 26, over little a, which I don't know, is equal to the sine of 118 over little b, which is 21.03, which is equal to the sine of c, which is 36, over little c, which is 14. Now, I'm always going back to that fraction that I had completely full when I started. Nothing is rounded there. Everything is an exact answer. So, I am still trying to find little a, so sine of 26 over little a is equal to the sine of 36 over 14. All right, Dennis, what are we going to do to find that little a?
Multiply sine of 26 by 14.
Good. 14 multiplied by the sine of 26.
And multiply the sine of 36 by a.
Good. A multiplied by the sine of 36. Cross multiplying. All right, Aaron, what am I going to do to get little a?
Divide by sine of 36.
Divide both sides by the sine of 36. Fantastic. All right, approximately what is little a? Does somebody have that? 14 multiplied by the sine of 26 and then divided by the sine of 36. 10.44 approximately, and that's in inches. So little a is about 10.44. I've solved my triangle. I know all of the sides. I know all of the angles. I do not quit until I know all the sides and all the angles. Yes?
So, do we have to write down the law of sines equation for every time?
I want to at least see the proportion you set up to solve.
About that, what sine 20, what would be a good sine there?
This, my initial beginning, yes, I want to see where you initially started. Absolutely.
Do we need a second one?
No, you don't necessarily have to show that one. Yep. Anything else? All right. All right. We're going to be looking today at a very special case. And this is a very special case that you did not talk about in geometry last year. It is called the side-side angle case. And if you remember back to geometry last year when you were solving two triangles congruent, you used angle, side, angle, side, 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 angle, side, angle, 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 side, side, angle, side. And I'm sure that your geometry teacher told you that there was a naughty one, a nasty one that we were not allowed to use. Side, side, angle. Usually they say if you write it, you are one. And we can read backwards. Don't call your teacher that. Okay? Now, what that means is side, side, angle, or naughty angle, side, side, is a situation that gives us an interesting situation with the law of sines. Okay? A side-side angle is what we call the ambiguous case. It doesn't quite know what it's going to do. The ambiguous case. We've got to figure out what it's going to do. In the ambiguous case, there is a possibility. It is a possibility, this is a situation where there could be 0, 1, or 2 triangles. Side-side angle is the only place that this can happen. There might not be a triangle at all. We might only have one, or we might have possibly 2 triangles that can be solved. Okay, in order to understand this situation, I'm actually going to show you a video off of YouTube. If you are looking to reference this video later because you're not quite sure of exactly what it was, you're going to look up law of sines, ambiguous case, and it's going to be the video that it's part 1. Okay? Now, I want you to realize, however, how this video begins because it's a little bit interesting. The gentleman on the video looks at a triangle that he draws with a 50-degree angle here. The height of this triangle is right here. And he chooses a triangle that has this side of 4 and this side of 3. Okay? And he does a little bit of math magic that I want everybody to make sure that they understand what is going on in this case. Is it not true that if I got rid of this part of my triangle, what type of triangle would this be? A right triangle. And h is what to 50? Opposite. And 4 is what? The hypotenuse. So is it not true then that I could say, well, the sine of that angle of 50 is equal to opposite, which is h, over my hypotenuse of 4? Okay? How would I get the h? I'd multiply both sides by 4. So the height is equal to 4 times the sine of this angle of 50 degrees. Okay? If I wanted to find this height, it would be 4 multiplied by the sine of 50 degrees. In this case, 4 multiplied by the sine of 50 is approximately 3.06. Okay? Now, I need you to understand then that whenever I'm finding the height, it is the sine of this angle times the side that is right here. Okay? The height of this is 4 multiplied by the sine of 50. Okay? He sort of says this and assumes that you're going to understand what he's talking about, and I want you to understand where it comes from. Okay? He's calculating on how to find the height of this triangle. Any questions with that? Okay.